Welcome to all the aspirants of GATE and ESE. So today we'll be seeing an important topic from your quantitative aptitude. That is what? That is exponents and powers. Yes, it's a we cannot say very important, but yes, important, because quantitative aptitude is one of the important portions of your aptitude for both GATE and ESE. Yes, and therefore it's very important that we study the exponents and powers, and also we put lot of importance for what? Your aptitude. Now aptitude consists a very big weightage as far as GATE and ESE is concerned, right? In GATE, from aptitude we get how many marks? We get 13 marks. So 13 marks out of 100 marks, we can say 13%, right? This is your general aptitude, right? This is your general aptitude. Now coming to ESE, this is for what? This is for your GATE. Now coming to ESE, when you're talking about ESE, right? So the general studies paper, right? The general studies paper, which comprises of what? 100 questions, right? 100 questions. And nowadays around 10 to 15 questions are asked from your general aptitude only, right? Because your GS consists of how many marks? As I told, 100 marks, not 100 marks, 100 questions. And out of this, you can expect how many questions? 10 to 15 questions from your general aptitude. So therefore it becomes very important that we put good amount of importance to these topics. Let us start the class without any further delay. Okay. So today, as I told, we are touching which topic? Exponents and powers. Let us first see some of the basic rules, and then we'll be solving questions. I'll be giving you time also so that you can solve the questions. Okay. So first of all, when I say exponent, so exponent form is what? The typical form is what? A to the power m. The typical form of an exponent, right? Now what is this A? This is known as the base. This A is known as what? This A is known as the base, and m is known as what? It is known as the power. Now most of the questions which you get in the examination in there, the base is what? The base is normally an integer, non-zero integer, right? Normally it is what? A non-zero integer, like what? Like 5, 2, 7, 9, yes, they're all non-zero integers. And this power is a whole number. This power is normally what? A whole number. It can be positive, it can be negative, yes, okay. So it can be minus 2.3, it can be 2.36, it can be 5.4, like this. This is what typical form of a exponent, right? Typical form of an exponent. Okay. Now there are certain rules. There are certain rules which you should know, which will be very helpful in solving the questions. Okay. Solving the questions. Okay. The first rule is what? If the base is same, if the base is same and you are doing a multiplication operation, you can see here is what? The base is same, right? The base is same and you're doing a multiplication operation, means what? A, power is different, a to the power m, a to the power n, and you're doing a multiplication operation, then what will happen? Then you can add the powers. Then you can add the powers. Easy. This is what? The base is same and you are doing a multiplication operation. Same thing, if the base is same, power are different, but you are doing a division operation, then what you will do? You will do m minus n. Very simple. If it is multiplication, then addition. Here addition of powers. Division, then means subtraction of powers. So that means what? If I am writing something like this, you see, 3 to the power 7.5 into 3 to the power 1.5. So here what is happening? The base is same and the power is different. In this case, what I can do? I can put the same base and add the powers because it is a multiplication operation. So what I will get? I'll get 3 to the power 9. Yes, same thing if it is what division, same thing if it is what division, then what I would have done, I would have subtracted. I got what? 3 to the power 6. It's a very basic rule. You might be thinking, sir, this rules we have studied in the childhood. Yes. Normally what happens, the aptitude which is asked in this competitive examination mostly are the portions which you have studied in your school only, right? What we need to do is that we need to revise them, compile them and solve some questions so that in the examinations you are not clueless. See, everything which you have studied in your class 10th or 8th or 9th, you don't remember now. Yes, you have understood at a certain point of time, but currently you don't remember it, right? Currently you have forgotten it, right? Therefore, there is a need that you remember those, we can say, formulas, yes, and then solve questions. So that we are doing here for you. Now, if we have a thing like this, a to the power m and then to the power n, then this can be written as what? A to the power m into n. Or I can say simply what? A to the power mn, right? A to the power mn, right? Now same thing, you see what is happening here. We are doing a multiplication. The base are different but the power is same. So what I can do? You can keep the power same and you can do ab to the power m. And same thing, it is a to the power m divided by a to the b to the power m. So I can say the base are different, power is same. So what will happen? It is a by b to the power m. So these are what basic rules. So welcome Sanvar, welcome Sanvar. Okay. Now next thing, a to the power 0 is 1. We know that identity, right? A to the power 0 is 1. We know that identity. And we also know that a to the power minus m is what? 1 by a to the power m. They are all what? Basics, yes? They are all basics which you have studied till now. Let us write down again. I am writing in a larger font. So a to the power m into a to the power n. Base same, power different. And you are doing a multiplication. So what will happen? You can add the powers. Then base same, powers different, and you're doing a division. So what you can do? You can subtract the powers, right? And then this is what? This is a to the power mn, yes? And if you have different bases but same power, doing multiplication, then this will be what? I can say ab to the power m. So using these identities, let us solve some questions. So I will be giving a question, I will giving you some time to solve. Around 2 minutes I will give for, at least 1 minute I will give for all the participants, okay? So let us start the question solving. So this is your first question. It's a very simple question. I'm starting with a very simple question and then we will see some more complicated question. So I request all the participants to solve this and give me the answer in the comment section. Please solve this and give me the answer in the comment section. Please do. I'm waiting for your answers. After you have done, then I will do. And you know, all these basics rules will be used. All these basics rules we have discussed, they only will be used in solving the questions. So please solve this. Now many students might think that these are all easy things. Yes, we might think that's all easy things. So let us skip this. No. In the examination, if you want to score full marks, you have to go through everything. See, if you don't study in details, what will happen is that you will get out of 13, 8, 9 marks and 4 marks you will lose. And here we are not to lose any marks. So if you want to score full marks, then you have to systematically cover everything. So please cover and tell me what is the answer to this. I'm waiting for answer. Please mention the answer in the comment section. 4.5, yes, easy question, yes, very easy question, yes. So you see, here it is 35 and then 35. So what is happening? So what is happening? Your base is same, right? Your base is same. Power is different. Yes. Let me make it suppose B. That question mark, suppose I am making it B. So we know that when the base is same, power is different, I can add them if I am doing a multiplication operation. So this is 3.5 plus B. This is 35 to the power 8. So by comparing the powers, I can say B is equal to 4.5. How? I can write down 3.5 plus B is equal to 8, and from here I can say b is equal to 4.5. So very basic thing we are starting, because in the examination it might not be that this question is asked in the examination, but yes, the concept will be same. So question number 2, so now solve this question. Now little complicated, right? Little complicated. Started with a very easy one, little complicated. So take your time and solve this question. I'm waiting for your answers. Take some time and solve this question. Try to use any one of the identities which I told in the initial part, right? Try to find out which identity I can use. Okay, I'll give you some hint. You can see here, base is same, power is different. So what identity you have to use, you know now. So please try and tell me the answer to this. Base same, power different. One observation I can give you hint is that you can see the sum of powers. You can see the sum of powers is how much? 3, 3, 2, 1. Yes, the sum of powers is what? This. So this one and this one, when you add them up, you are getting this value. Now solve and tell me the answer. You can consider this 1.001 as suppose something called A, suppose. Because that's suppose something like A. Yes. So it is written what? A to the power 1259 is equal to 3.52. Yes. And then A to the power 2062 is equal to how much? 7.85. 7.85, right? 7.85. Yes. Now what is written here? What is this? This I can write down as A to the power 3321. This can be written as what? A to the power 1259. Then what? Then A to the power 2062. Or I will add it up. Add it up. Yes, like this. I can write down like this. Yes. Easy. Now this is what? Addition. So this becomes what? A to the power 1259 into A to the power 2062. So it becomes multiplication, right? Since the powers are added, so when you separate them with same base, it becomes a multiplication, right? It becomes a multiplication. Okay. So this is your GATE ESE civil mechanical channel, and we are taking a YouTube live lecture, yes, to all the participants. Okay. So now tell me the answer now. Now tell me the answer. Now tell me the answer. Now tell me the answer. You see what you did, Ansi and Anwar, what you did, you multiplied. You added. You have multiplied, right? So the answer you have done is wrong actually. Yes. You should have multiplied. You added them up. Yes, you should have multiplied. Now tell me the answer. The answer is not C. The answer is not C. You multiplied. You added instead of multiplication. Now tell me the answer. Now tell me the answer. The answer is D, right? The answer is D. It is not C. It is not C. So see, you see, such basic questions which we feel that is very easy, we might commit mistakes. Yes or no? It appeared easy, but we might commit mistakes if you are not using the identities properly. So here it was A to the power m plus n. This becomes what? A to the power m into A to the power n. So here I can say this was m, this was n. Yes, this was m plus n, so became what? A to the power m into A to the power n. So it is multiplication. Understood? Very good. Let us solve the next question. Let us solve the next question. Okay. Little easy question. Let us first you try, then I will solve for you. First you try, then I will solve for you. Here you can use this identity. A to the power minus m is equal to 1 by A to the power m. So I am giving you some hint, okay? I am giving you some hint. So try to use this and solve the question and give me the answer. I am giving you some hint. Try to use this and solve and give me the answer. I'll wait for it. Okay, so what is the answer? Ladies and gentlemen, what is the answer to this? First of all, you see it is m by n to the power x to the power minus 1. Yes, it is an n by m. What I can do? I can write this expression as m by n. Yes, and then this becomes what? 3 minus x. Yes or no? It is what? 3 minus x. Why? Because when you are taking the reciprocal, then the power changes from positive to negative. Yes, so this can be written as, I can write down like this. You see, n by m to the power x minus 3 is equal to m by n to the power minus x minus 3. Yes, so this becomes what? M by n to the power 3 minus x. So now tell me the answer then. Now tell me the answer. Now tell me the answer. Now from here what I can do? The base is same, so you can equate the powers. So x minus 1 is equal to 3 minus x, or 2x is equal to 4, or I can say x is equal to 2. Nice. Easy. So answer is C. Next question. Now you solve this for me. Okay. Next question is this. So students, I will give you some time, you solve, and then I will solve for you. I'll wait for your answer. Come on, solve it. Okay, some students have answered C. That's correct. That's very good. You see, this is given as m. So, and this is given as n. This is m and this is n. Now, what is written? M to the power p. So, m to the power p can be written as what? 10 to the power 0.48 and then to the power p. Yes. Now we have an identity for this. What is that identity? A to the power m to the power n is what? A to the power mn, right? So this becomes what? 10 to the power 0.48p. Yes. Similarly, n square. What is n? 10 to the power 0.7. Now this square becomes what? 10 to the power 0.7 into 2. Making it how much? 1.4. Now these two are given equal. Yes, these two are given equal. So what I can do? 10 to the power 0.48p is equal to what? 10 to the power 1.4. The base is same, so I can equate the powers. So here what I can write down? 0.48p is equal to 1.4. I can say p is equal to how much? 1.4 by 0.48. Approximately I get how much? Your 2.9. Little less than 3. So approximately it is 2.9. Yes, we use this identity. We used this identity. Fifth question. Okay, solve this, very easy. Solve this question, very easy question. See, as we solve more questions, that it will be little difficult. Yes. See, the question will be difficult than this, but the basic identity which you are using will be same. So if you are solving any questions of power and exponents, so you will be using these identities only, right? So this is the practice session for all the students, so that they get acquainted with these identities. Now once you get acquainted with these identities, then you can solve tougher questions also. Yes. So this session is not to solve all the difficult ones. Yes. This session is not about solving all the difficult ones. Yes, some questions will be directly asked from like this also. Because GATE and ESE, you don't expect too tough questions. But yes, they will ask some good questions, some simple questions. But the basis will be these identities only. Okay, now solve this question. Yeah, solve this question. And try to understand GATE is not some mathematical Olympiad. They will not ask too tough questions also. But yes, what happens is that when we are studying engineering, yes, we forget the basic identities which we studied in what? In your school level. And therefore, GATE asks such questions from your basic identities also. Yes, so please solve this and sorry, not this question. Sorry. Yeah, this question. Answer this question. Very straightforward question. So, solve it. Okay, very straightforward question. You see, this you can write down as what? 5 to the power a minus 3. This is what basically? This is 5 to the power a by 5 to the power 3. It's simple, right? And this is what? 3125 divided by this is what? 5 cube is 125. So if you solve this, you are getting how much? You are getting an answer of 25. Very basic question. The next question, please solve this. Let's solve this question. Let us see how many solve this question. Very easy. You can use different identities. You can use this identity. It will be easier for you to solve this. Okay. Solve this and give this identity use and solve this question. Chalo. See, if I write this identity here, you see 3 to the power m plus n. Yes, you see base is same, power is different, and you're doing a multiplication operation. So what you can do, you can add the powers. This is 3 to the power m minus n plus m plus n. So n get cancelled. You get what? 3 to the power 2m. Yes, and this is what? This is 27. And this is 243. So write down 27 into 243. Yes, now you can solve this. This is, by the way, how much? This is 3 to the power 3, right? Yes, and this is 3 to the power how much? 3 to the power 3 is 27. 3 to the power 4 is 3 to the power 4 is how much? 81, and this is 3 to the power 5. Yes, so I can say this is 3 to the power 8. So I can say your 2m is equal to 8 by equating the powers. Yes, and m is how much? M is 4. If m is 4, what is n? Very easy. 3 to the power m minus 1 is 27. That means what? It is 3 cube. So from here I can say what? M minus n is 3. So m is 4 means 4 minus n is 3. So n is 1. Easy. We can solve this question in different way also, by other ways also, okay? There are many ways. I just used one way. Next question. Solve this question. Very easy question. You have to find out this question mark. It is written 5 to the power, this question mark means 5 to the power, the power is asked. Okay? So very simple question. Okay? Solve this. So I'll give you a hint. I'll give you a hint. Convert everything to 5 to the power something. Hint is convert everything 5 to something. It is what? 5 to the power 2 to the power 7.5 into 5 to the power 2.5 and is divided by 5 to the power cube and then 1.5. Now tell me what is the answer then? Now tell me what is the answer now. Okay. Now we use this identity. Remember, a to the power m whole to the power n is what? A to the power mn. Now use this identity and solve and give me the answer. Come on. Come on. Okay, solve. See, these questions, if they ask you 1 mark question. Yes, they will not ask you 2 mark questions in this. All these questions on exponents and power, mostly they will ask questions from what? 1 mark question. Okay. What's the answer to this? Hare Baba, this is 5 to the power, you see 2 into 7.5, right? Then 5 to the power 2.5 divided by how much? Divided by 5 to the power 3 into 1.5. So this becomes what? 5 to the power 15, then into 5 to the power 2.5 divided by 5 to the power 4.5. Now what happens, you see? Here we are doing multiplication, same base, different powers. So I can add the powers. So 15 plus 2.5 divided by 5 to the power 4.5. So this becomes 5 to the power 17.5 divided by 5 to the power 4.5. Now you are doing division, same base, different powers. So I can subtract 17.5 minus 4.5, making it how much? 5 to the power 13. That question mark is what? 13. Yes. Next question. Okay, so many things. So you see now things are becoming little complicated, right? As I told, I started with very basic things and now things are becoming little complicated. Yes, now solve this and give me the value of this. Okay, what is the value of this? Solve this and give me the answer. I'll wait for some time. Okay. Hint is convert everything in the power of 3 and then use the identities which I told you initially. B, okay, B or C to this answer. This is answer C or B or A. Which one? C. 3 square is 9. Yes, 3 cube is 27, sorry. Yes. 3 to the power 4 is 81. Yes. And 3 to the power 5 is your 243. So this is 3 to the power 5 and then whole to the power n by 5. Yes. And then we have 3 to the power 2n plus 1 then divided by 3 to the power 2 to the power n and then multiplied by, multiplied by 3 to the power n minus 1. Yes, this is written, right? I converted everything in the power of 3. Now I will use this identity. Which identity? A to the power m to the power n is what? A to the power mn. So what will happen to this? This becomes 3 to the power 5 into n by 5. Then multiplied by 3 to the power 2n plus 1. So what will happen? This 5 get cancelled. I get what? 3 to the power n. Then divide by 3 to the power 2n into 3 to the power n minus 1. Yes, 3 power n minus 1. Now see this. Now see this carefully. Now see this carefully. When I am writing this as a to the power m into a to the power n, it is what? A to the power m plus n. Yes, a to the power m plus n. So what will happen here? You see, this becomes 3 to the power 2n plus 2n plus 1 divided by what? 3 to the power 2n plus n minus 1. Yes. So now what happens? This becomes 3 to the power, this is n only, sorry. So 3 to the power 3n plus 1 divided by 3 to the power 3n minus 1. Yes. So what you get? You get, you see this is division, right? This is division, right? This is 3n plus 1, 3n minus 1. This is division, right? So I can say a to the power m by a to the power n, right? Division, right? So what you can do? This becomes a to the power m minus n. So this is what? 3 to the power 3n plus 1 minus 3n minus 1. So this becomes what? Plus 3n get cancelled. 3 to the power 2, that is how much? 9. You see? So you see, same identities, right? Same identities, but they can complicate the questions like this. Yes? And if you want to solve these complicated questions, you have to use the same identities. So if you solve a simple question, identity is same. If you solve a difficult question, identity is same. The identity will not change. The identity will not change based on what? That the question is simpler or difficult or complicated. So this was my aim to what? To convey to you. Yes, and hope that message is conveyed. Next question. Okay, solve this very easy question. Solve this very easy. I will solve this for you. This is 256 to the power 0.16 and then 256 to the power 0.09. You can see the base is same. Powers are different. So I'll add them, right? 0.16 plus 0.09, making it how much? 256 to the power 0.25. Yes, now this becomes how much? 256 is how much actually? It is 2 to the power 8, na? Because 2 square is 4, 2 cube is 8, 2 for 4 is 16, to the power 5 is 32, then 6 is 64, and then so on, 8. So this becomes what? 2 to the power 8, and 0.25 is 1 by 4. So it is 2 square, making it how much? 4. So answer is what? 4. Simple question. Okay, now solve this and tell me. Now this is little complicated, right? This is little complicated. So please solve this question and tell me using the identities. Okay. This question is little difficult, right? This question is little difficult. It is not that straightforward. So now this question you solve and give me. It is what? This whole expression is converted into what? 21 to the power something. So solve this question and give me the answer then. Solve this question, give me the answer then. You see, here what you can do, I will tell you. You see, this 21 can be written as 3 into 7, right? Now convert everything in the power of 3 and 7. You see, This is 3 to the power 3.5. I'll use different ink. This is, you see, this is 3 to the power 3.5. Then 21 is what? 3 into 7, right? 3 into 7 to the power 2. So this can be written as what? 3 square and 7 square, right? Then 42 is what? 42 is 2 into 3 into 7, right? Basically 6 into 7, so 2 into 3 into 7. Now to the power 2.5, so this makes it what? This makes it 2 to the power 2.5, 3 to the power 2.5 and 7 to the power 2.5 into 7 to the power 3.5, this term. Yes. Now whole divided by 2 to the power 2.5. You can see this term and this term is getting cancelled. Now there is no need to find out the power of 3 and 7 separately. You find either power of 3 or power of 7. It should come same, na? Because it is 21 to the power something. So power of 3 and power of 7 should come same. So just see the power of 3 here. It is 3.5. You are doing a multiplication, so plus 2. Then doing a multiplication plus 2.5. Getting how much? Getting this as 3 to the power 5.5 and then 3 to the power 8. See, if you want to find out the power of 7 also, you'll get the same answer. You see, 7 to the power, you see 2, okay, plus 2.5, 2 plus 2.5 and then plus 3.5. So how much are you getting this? You're again getting 7 to the power 8 only. So what is this question mark then? This question mark is 8. Yes. So you can see that such kind of complicated questions which is appearing complicated, yes, appearing complicated, but they can easily solve them by just applying the basic identities which I told at the beginning of the lecture. Okay. Now this is your homework then. Okay. This is your homework. So question number 11 is homework. So we solved 10 questions. So question number 11 is homework. Okay. And question number 12 is also your homework. Question number 12 is also your homework question. Okay. So 2 questions I am giving you homework. Please go through the question and solve them using the same identities. So ladies and gentlemen, this was a short lecture on what? The exponents and powers. Yes. See, I am not doing logarithmic in this class. I will do logarithmic, a detailed class in some other class. So this, the heading is written exponents and logarithmic, but actually the heading should be exponents and powers. It was miscommunicated from my side. So logarithmic I will take a separate class some other day. Okay, logarithmic is a very important topic, okay, for your GATE and ESE examination. So logarithmic will be the next class which will be announced in the channel. So stay tuned and subscribe to the channel, right? So stay tuned and subscribe to the channel. Okay, subscribe to the channel. Yes, subscribe to channel so that you can get the notification. Very nice. And solve these 2 questions and mention the answer in the comment section. Okay. So great interacting with all of you. And we saw that by understanding this basic identities of exponents, we can solve easy question, difficult question, everything. Okay. Thank you very much. See you in some other video.